Just look at this seed. It weighs under a gram. It looks pretty ordinary. But what it'll become is truly extraordinary. These are giant sequoias. Some are over 3,000 years old. And sequoias are the largest single life form on Earth. All from a tiny seed. Yet even that pales into insignificance compared to what the whole of the plant kingdom has done throughout the history of our planet. They harness light from the stars, bringing energy to our world. They created our life-giving atmosphere. They sculpted the very surface of the Earth. And they drove the evolution of all animals, including our own ancestors. It's a whole new story about our Earth. Told through remarkable images, captured for the very first time. This program is about just one type of plant, the most underrated, but perhaps the most important of all. One that, by taking on and conquering the rest of the plant kingdom, shaped the face of the planet and went on to help create human civilization. This is the story of grasses. For hundreds of millions of years, throughout the time of the dinosaurs, forests ruled the land. It was so warm, trees extended over most of the Earth. Imagine the Arctic and Antarctic without ice, carpeted with forests. Welcome to the planet of the trees. Today, isolated remnants of those expansive forests still exist. And here in East Africa is one of the most impressive. The Kasagoo cloud forest rises out of the dry plains of Kenya. Cloaked in moisture, it's much the same as it was then. Back then, trees ruled, because wood gave them the strength to grow ever taller and to gorge on the sunlight all plants need. As you descend, you get a real sense of how trees bully and overshadow everything below. But it's not complete gloom. Patches of sunlight do break through to the forest floor. And those shafts of precious light provided the niche for a new type of plant, one that would come to take on the trees. So how did scientists discover the identity of the challenger? It was all thanks to dinosaurs. This is a sauropod. And when scientists analysed it a few years ago, they found it contained something really strange. Under the microscope, the scientists saw a fragment of a plant. It had a distinctive pattern, these figure-of-8 nodules. They turned out to be the defining feature of a family of plants they were astonished to see. The grasses. It was from 66 million years ago, evidence for the earliest grass ever found. called livelihoods. From its humble birth, grass would go on to be one of the most important forces on our planet. You can still find descendants of those early grasses today. We think these are similar to what the first grasses must have looked like. You can imagine them struggling away on the forest floor. But the dinosaurs' days of grazing were about to end abruptly. "65 million years ago, an asteroid 10 kilometers across killed them off. The grasses survived, but in turn, they would face their own crisis. What was coming had nothing to do with the plants and animals that lived on Earth. It was all to do with the atmosphere. And that was changing for the most surprising of reasons. Our air contains carbon dioxide. It's the gas that plants need to breathe to stay alive. But between 50 and 30 million years ago, this gas began to disappear, threatening all plants. The crisis started with the creation of huge mountain ranges like the Himalayas. The biggest period of mountain building in Earth's history. The freshly exposed rock was washed away. Some of the minerals ended up in the sea. And here they sucked the carbon dioxide gas out of the air, combining with it to form an entirely new type of rock. Limestone. By 30 million years ago, as the mountains had risen, the level of carbon dioxide fell. In fact, carbon dioxide levels dropped to a sixth of what they had been beforehand, which is an enormous fall. And for the plant kingdom, it meant crisis. Without enough vital carbon dioxide, many plants, including the grasses, were struggling to survive. One way to reveal the impact this had on plants is to look at a clever bit of human machinery. The car engine. Because what's under the bonnet shares surprising similarities with plants. The car engine relies on two things to work. It needs petrol and it needs oxygen from the air. Inside the engine, these two are combined to release the energy to power the car. It's called combustion. Like the engine, plants also need a gas from the air to work. In their case, the carbon dioxide. So for plants, the collapse of carbon dioxide levels was similar to a car engine starved of oxygen. When the air intake is blocked, the engine stutters away because it's struggling to get the oxygen that it needs to work. With less carbon dioxide in the atmosphere, plants also began to stutter. But the grasses were evolving a new and ingenious invention. Again, the engine provides a parallel. There's a piece of shiny machinery here that any petrol head will recognise. What it does is force more oxygen into the engine. It's called a turbocharger. More oxygen means that the petrol burns more fiercely. And that means more power. Evolution often comes up with their cleverest solutions during desperate times. And one group of plants, the grasses, turned this crisis into an opportunity. Acts as a miniature pump, sucking in and concentrating vital carbon dioxide. So although there was less carbon dioxide in the air, the grasses had the edge over other plants. But forests still ruled the world. The huge trees had also survived. Then the underdog unleashed a devastating new weapon. "8 million years ago, by now the climate had altered. Much of the earth was drier than ever before. It was the moment grasses had been waiting for. The grasses had evolved unique properties that made them especially flammable. When dry, they became like a tinderbox. All they needed was the spark. Today, there's an ideal place to see what happened 8 million years ago. Here in the national parks of South Africa, rangers deliberately start huge fires to manage the land. It's the perfect opportunity for Chief Firestarter Chris Austin to see how grasses first exploited flames.
Thanks, Spotter 3. Thanks up.
He coordinates the helicopter crew as they drop fire capsules onto the grass. Artificial lightning strikes.
The capsule lands in the grass and it takes about 46 seconds for the chemical reaction, which is the potassium permanganate and the glycol to react. And then it ignites and that starts the fire. If you put the capsules down every 10 meters, they join up and they form one continuous line of fire. It becomes a war.
Grassland fires are particularly fast-moving, as Chris Austin has experienced.
The most aggressive fire that I've seen moved at more than 3 meters a second, which is really quick. You can't outrun it. The fires that kill people are grassland fires because they're so fast moving. And when the wind changes, they change direction just as quickly.
And that's not all. Grass burns in a special way, a way that was devastating to its enemies. To discover more about its unique properties, a scientist has volunteered to enter right into the heart of the fire.
You're wired for fire.
Yeah, wired for fire.
So what happens next?
So we want to make sure you're safe.
Bless you.
You know, and when you're outfitting firefighters, you build in a safety factor.
And this is designed mainly for oil refinery fires and things like that,
It'd be well
industrial
suited
things.
for industrial fires. It's designed so that a human being can actually be in a fire for a few minutes. It's called a fire entry suit.
Once in the flames, the heat sensors of the suit will be combined with the readings of a thermal imaging camera to reveal the secrets of a grass fire. Grass fires are very different from other fires. The readings show that the hottest area of the fire, the white parts on this image, is not in the burning grass, but a metre above it. The temperature here is over 360 degrees. Grass ignites more easily than other plants and is transformed into a volatile gas. This gas rises and burns even hotter than the grass itself, making it one of the fiercest and fastest fires in nature.
It was actually quite a privilege to be in there. You know, normally if you're stuck in one of them, you just don't come out. What was amazing is, I always thought that kind of a wildfire would be all over the place, but it's a really fast wall of flame that just comes shooting past you, and it's just the speed of it. You kind of feel sorry for the trees.
The next day, the fire still smoulders. It's so strange. Why did grasses evolve to encourage fires to take hold? Ripping through the landscape and destroying plant life. It seems suicidal. Grasses don't just encourage fires to start, they're also designed to survive them. In fact, they're the most fire-resistant plant on Earth. The solution to how grasses can survive isn't on the surface, it's just below. If you open up the stalks, you can see there's a little bud stuck under an insulated thick coating, and that's still alive.
Look at this. I mean, come back in 2 weeks' time and it'll be green. It'll start greening up.
But everything else, such as a tree, is dead.
In this situation, definitely grass is the boss. Fire like this will control the small seedlings. So they'll keep the number of trees in an area within a certain limit. As soon as you keep fire out the system, the area becomes moribund. You find that the grass starts to die off, and then the seedlings get a chance to get through. They get above a certain height, and then the fire doesn't play a role in controlling them. Grass thrives on fire.
Yeah.
If you take fire out the system, grasslands go backwards. They actually become unhealthy.
This could easily be a scene from 8 million years ago, where the grasses recovered and recolonized. The sneaky bit was they did it much faster than trees. In the wake of this onslaught, the forests started breaking up. The grasses were on a land grab, conquering the territory once held by the trees. The expanding grasses turned Earth into a flammable planet, a fireball world that must have seen a million trees burn and black ash fill the sky for hundreds of thousands of years. For the trees, this was apocalypse. The world was ablaze. The Challenger had sparked a revolution that was changing the face of the planet. But the global rise of grasses wasn't just reshaping plant life. It was transforming the animal.
Enough to find that the enamel of horses' teeth is an excellent record of what they've been eating all the way back into the ancient time.
This graph is the result of the scientific analysis of teeth enamel of horses from North America.
It shows us here prior to 8 million years ago that horses were basically browsing in the forest. They were nibbling on shrubs, on tree leaves and so on. Then there was a sudden and very dramatic spike in the grass component of their diets as reflected in the tooth enamel.
This sudden switchover was not confined to North America. It happened in South America, in Africa, in Asia. In a period of 1 million years, a geological instant, the world's herbivores dramatically changed their diet so that they were eating the new grasses. This discovery proves that by 6 million years ago, grasses were dominating the land. It was a domination that would have striking consequences for many animals. And it involved another piece of clever engineering from the grasses. It's something most of us have all done at one time or another, cut ourselves on a blade of grass. It's actually all to do with something that coats the edge of the leaf. grass extracts a mineral called silica from the soil. The silica is built into row upon row of tiny daggers along the leaf. It's a defense to discourage animals from eating it. Although tiny, these weapons led to one of the biggest extinctions of mammals in Earth's history. The world had been full of many different plant eaters, including the vast Baluchitherium. These 20-ton beasts were the largest mammals ever to exist. They fed off trees and shrubs, but as their food source disappeared, these animals died out. In North America alone, grasses led to the extinction of over half of all plant-eating mammals. But some herbivores thrived, and Don Gayton can reveal how their teeth helped them deal with grass.
In this skull of a modern horse, he's very large, flat teeth, durable enamel, so they were able to take a mouthful of that grass with all that high silica content, grind it laterally like that, break down the silica, and make it more digestible.
By 6 million years ago, the triumph of grasses had caused the death of many types of animals, while creating vast herds of new ones. The more familiar plant eaters we know today. But that's just the start. Because if you've got herbivores consuming silica-rich grasses, all that mineral has to go somewhere. As manure. The herds of herbivores were producing millions of tons of manure every day. It's washed away into rivers until finally it reached the ocean. And within it was all that silica. It's out in the oceans that things really began to take off, because out here are creatures which are addicted to silica. Alien architecture. But essential for the construction of their tiny skeletons is silica. "5 million years ago, they were feasting on huge amounts of silica from the grasses. And diatoms are crucial because they form the foundation of the ocean's food chain. With more diatoms came huge shoals of anchovies and herring that eat them. This in turn attracts predators like seabirds and dolphins, and even bigger hunters. A once forested planet was now dominated by open plains. "8,000 different species of grasses covering a quarter of all land. They'd selected which animals would live or die. And they'd fundamentally altered the oceans, playing a crucial role in the makeup of our atmosphere. Yet, perhaps the most important impact of this remarkable plant was still to come. fascinating to anthropologist Jill Preetz. She's most interested in parallels between the remarkable behaviours of these chimps and what could have happened during the evolution of humans. Jill has spent 10 years studying the Fongoli chimps.
This really is the first place where we've been able to habituate chimps to our presence so that we can follow them and study them in this habitat, and it is different. It affects their behavior significantly, and every difference that you see between chimps living here and chimps living in a forest can be traced back, linked back to the habitat. I mean, I think the chimps are pretty smart here, and you know, I'm a little biased towards my own study group, but I think they're pretty intelligent, and they have to adapt to a different type of environment, and that's what brings out the most exciting findings, I think.
The Fongoli chimps have human attributes. They're proficient at using tools, such as sticks for collecting termites. Many chimps in Africa catch termites in this way, although these chimps do it more than any others. But what makes them really special is another hunting technique, one that is unique.
Well, I think that probably the most exciting discovery we made was that they hunt with tools, which before we had thought only humans did. They'll fashion branches into sort of like a spear, and they'll use it to jab into these tree hollows where you have another kind of primate, a bush baby, and then they jab it into the hole.
Jill's filmed this remarkable behaviour, the first time it's been recorded. It shows a chimp using a spear he made to stab and kill a small mammal, a bush baby.
I love the chimps, and I'm really interested in them for their own sake, but one of my main reasons is really to get at what could have happened 4 to 6 million years ago when the first bipedal apes, hominids, were around and used the same type of environment, a grassland type of environment. And I mean, I think the chimps here can tell us something about that.
The chimps of Fongoli are the only ones in the world that have been observed using spears to hunt mammals. Jill believes they've had to come up with this behaviour to cope with the harsh and dry grasslands. It's a more hostile habitat than the forest, so the chimps here have to be smarter. And Jill has discovered a final extraordinary behaviour of these chimps. It also reveals more about how our ancient ancestors might have evolved as they moved out of the forests.
So this is actually a clip I took in the wet season, and the chimps are in a grassland. When they enter the grasslands, they are obscured by the grass, so the grass is just over their back. And one thing they do is they'll stand up and look around. They have to scan. That's the only way they can really see. And so we see that quite a lot, actually. The key is that chimps elsewhere don't have this type of habitat. They don't have grass. They live in a forest, and you have a completely different type of environment. So it really is the environment, the grassland, that is driving the differences in behavior that we see.
Many scientists think this is perhaps a mirror of what happened as our own forebears stood up on the grasslands for the first time. It allowed them to keep an eye out for predators and prey, and eventually to evolve walking.
So I think it does give us some insight into how early humans may have reacted to the same grassland.
Because they But here in southern Turkey that archaeologists believe they've discovered why that revolution happened. The place is called Göbekli Tepe. It's one of the most exciting sites of modern archaeology because these are some of the oldest buildings in the world. They are 3 times older than the first Egyptian pyramids. And there's a real mystery here. Who built Göbekli Tepe? And more importantly, how could they have done it? This astonishing structure is 12,000 years old. It lay buried and undiscovered until 1994. The archaeologist who unearthed it is Klaus Schmidt.
Yeah, here we have a masterpiece of craftsmanship. We have the stilized human being depicted in a very, very stilized scale, and we have this high relief of a leopard. One thing is very important, never a face is depicted. They are always faceless. Big question is, who are they? What we are doing here, we add a chapter in world history, a chapter which we didn't know it exists before.
To construct Göbekli Tepe with its 50-ton megaliths would have needed a huge army of well-organised workers. Yet 12,000 years ago was the Stone Age, a time when people were supposed to be hunter-gatherers living in small groups. How did they sustain the numbers essential to build such a vast temple? The answer lies a short distance away. Within sight of Göbekli Tepe are the Karacadag Mountains. Here something happened at this time that would change our world forever. It was all to do with one particular type of grass. It's an ancient type of wheat which grew totally wild just as it does today. It's called einkorn wheat. Yet collecting it presented a huge problem. Evren Jabi is an expert on early wheat. When the head of the wheat is ripe, just the tiniest of touches and it scatters everywhere.
Bu yüzden bundan ekmek yapabileceğimizi düşünemiyorum. Bu yerden toplamak çok daha zor olacaktır. Bunu izin verirseniz göstermek istiyorum. Çok kolay bir şekilde ufak bir basınçla Zaten rüzgarda da çok kolay dağılıyor. Hemencecik kırılıveriyor.
Frankly, it's hard to believe anyone would bother. But everything was about to change, triggered by a crucial event. A tiny alteration in the genetic makeup of a wild wheat plant. Just one gene in just one single plant. That mutation has been traced back to here, just 30 kilometres from Göbekli Tepe. If you look closely, you can see the difference between the two types of wheat. In the original wild wheat, a special ridge of cells between the stalk and the seed breaks down as the plant ripens. And this allows the seed to fall away. But in the wheat with the genetic mutation, these cells remain as a solid band. It means the new wheat never lets go of its seeds.
Tek bir genin mutasyona uğramasıyla buğdayın başakçıklarını bir arada tutan, yani tohumlarını bir arada tutan eksen daha güçlü hale geldi. Ve bu buğdayın tohumlarının yayılmasını güçleştirdi. Bu buğdayın tohumlarının yayılmasının güçleşmiş olması buğday için iyi bir şey miydi? Hayır, kesinlikle değildi. Peki kimin için iyiydi? Hayvanlar aleminin üyesi olan sadece bizler için iyiydi.
Because the seed remained on the stalk after it had ripened, it meant that not only could the people who lived here collect more grain, they could also begin to farm it. In other words, they could take some of the spare seed at the end of the season, put it back into the ground, and harvest the new plants the following year. It was the dawn of domesticated wheat.
Bu elimde bulunan dünyada ilk defa kültüre alınan buğday. Dünyanın en eski buğdayı bu elimde bulunan buğday. Ve bu arkeolojik kazılarda çıkartılan bir buğday. Gerçekten çok değerli. İnanılmaz değerli ve dünyanın en eski buğdayı bu.
And this wheat gave us bread. A fabulously concentrated form of energy. It could be carried, could be divided up, and could be stored. And in turn, bread would lead to something even bigger. The mystery of Göbekli Tepe was solved. In order to build Göbekli Tepe, the Stone Age people turned their back on hunter-gathering. They became the first farmers. "12,000 years ago, they began to sustain themselves with bread, made from the grass we call wheat. Now they could feed the huge workforce required to construct such a vast and sophisticated temple.
People had been hunter-gatherers, and now this site marks the end of their time, the end of their period, and the beginning of a new age. The people being in Göbekli Tepe are the first people having bread also in their villages, not only here, but also in their villages. It's a turning point in world history.
Human beings had now invented a way of harnessing the power of plants. And once invented, it could never be reversed. Because farming allowed us to come together in bigger and bigger groups, to build villages, towns, and eventually cities. Over the series, we've seen how plants gave us the oxygen in the atmosphere. And we've discovered how plants shape the animal kingdom. We've watched as the rise of flowers painted a drab world with brilliant colour. And for us, the humble grasses played the most important role of all. They drove the rise of our ape-like ancestors and ultimately triggered the birth of civilization. Plants made us and the world we live in.